In this video, I will show you an example about how to transform nonlinear model to linear model. In a class, students were tested on the final exam. Then they were retested with an equivalent test at subsequent time intervals. Their scores after time t in month are given in the table. Try to fit linear, logarithm, and exponential functions to the data by comparing the values of correlation coefficient R to determine the function that best fits the data. Compare the different regression lines on the same graph. First of all, I will copy the table to this Excel. Paste the special test. Okay. So for the logarithmic model, we will work on natural log of t. Then here is y. For exponential model, we will figure out t and natural log of y. So for natural log of t, you will get the equal sign. Then type ln natural log. Click this cell, then parentheses, enter. Then find this plus sign, keep going, so that you can get the natural log of t. Y will be the same as this cell. This time, it's t is the same, so click here, enter. Then drop down. Remember, put the equal sign, natural log. So you have the table ready for the data in the Excel first. Now let's go to this decimals. First of all, I need to add note. So I type in linear model. Then add one more. I need to copy the original table here. They show you this is a x1, y1. After you paste this table, you could say the decimals already showed you this scatter plot. Then we need to add a regression line, linear regression equation here. Put the y, this symbol. I need a y1 because here show you y1. Then use tilde m x1. Don't forget here's x1. Then plus b. The decimals will show you the correlation coefficient R over here, the M and B over here. If you don't want this graph show over here, you can unhighlight here. Using the same way, you can get a logarithm model and exponential model after you transfer them into linear model. So for linear model, the correlation coefficient R equals negative 0.984. For logarithm model, the R equals negative 0.9401. For exponential model, the R equals negative 0.9964. So you could say exponential model is the best fit. Now I go back to the Word document. I will copy the table from Excel. For here, you make sure it's a math type. For linear regression line, we got this from decimals. Remember, this x1 is a t, y1 is y. In this way, we got the linear regression equation like this. For the logarithm regression line, this is we got from decimals. Remember your independent variable, it will be natural log of t. So when you write down the linear regression model, you need to change this x2 into natural log of t. For the exponential regression line, this is given by decimals. Remember here, y3 means natural log of y. x3 is a t, so we will write down this way. Then both sides we do the e to the power. Then you simplify, change into this form. 0.949 is given e to the negative 0.0522. 93.410 given by these expressions, so that you will get this exponential regression equation. For the correlation coefficient for exponential regression equation is negative 0.996 and R squared equals 0.993. Now let's go back to the decimals. You will put those three regression lines over here. Then click here to change the x-axis and the y-axis. For the x-axis, I put the negative 5 to 30. For the y-axis, I put 20 to 100. I want to label the x-axis time in month. Y-axis is a score percentage. The steps, I put both 5. After this, you can click here, export the image, then download. After you download, then you can copy this image to the Word document. I pasted this image on the Word document. Then you can edit. Now we can draw the conclusion through these steps. First of all, we got the table from Excel. Then we use decimals to work out the linear, logarithm, exponential regression equation. By comparing the correlation coefficient, we can draw a conclusion that the best fit is the exponential model. Y equals 93.410 times 0.949 to the t power. This is the graph for different regression line. Red is the exponential model. Black is the logarithm model. Blue is a linear model.